us to find everything. So I will get my table going right away. F prime, f of x, and f double prime. I saw in some of your homework you put f prime and f of f prime. That's fine. F of x and then f prime. That's fine. Let me explain why this is, I think, better if you put f of x in the middle. Only because when you look in the middle, then you can look up and down. See if it's increasing, decreasing, opening up, opening down. If you put the function up here, it will be more difficult to look down, I think. But if it works for you, it works for me. That's fine. Can anyone give us the domain of this function?
Is it negative infinity to positive infinity?
Absolutely. Thank you very much. It's a polynomial function. It must be all real numbers. Good. So now I would like to find f of 0. Can anyone give us f of 0?
Would f of 0 just be 0?
Thank you very much. Great job. Indeed. Now, can anyone give us the limit as x approaches negative infinity from f of x, and also limit of f of x as x approaches negative infinity? And explain to everyone else why.
So we'd have to use the as it approached infinity, it would approach infinity.
Oh, I'm sorry. Which one you want to give us?
For negative infinity, would it go to infinity, and for positive infinity, would it also go to infinity?
Right, because these terms are too small to mention. That is the one that dictates. So if I plug in here infinity or negative infinity, doesn't matter. Both will be infinities. Very good. Is that clear, everyone? Here are my props. Okay, very good. So now we have to find f of x equals 0, which is 3x to the fourth minus 24x cubed plus 30x squared equals 0. How do we address this? Anyone? Anyone else I haven't heard yet? I heard Savannah and Haber. Anyone else?
X would be equal to 0, so it would be, we plug in 0 for all the x's.
We have to factor. We already did that. We are trying to find something else. So this was the y-intercept. Now we are looking for the x-intercepts.
Did you pull out 3x squared?
Yes, I will divide by 3, which will not make any difference. So I have x to the fourth minus 8x cubed plus 10x squared equals 0. And only now I will factor out indeed not x but x squared. You probably said x squared. My apologies if I misheard. So then what do we have left in parentheses? Anyone else I have not heard yet?
X squared minus 8x plus 10.
X squared minus 8x plus 10. And anyone else who hasn't spoken yet, so to give us the factor form, please. Shvam or Noor? Anyone?
Wouldn't it be x minus 6?
You are correct. You are correct. It's not
6 and 2. Sorry.
It's not factorable. You're correct. That's what I was hoping I would hear. Yes, Amanda, you're correct. It's not factorable, right? So I cannot find two numbers whose product is 10 and whose sum is negative 8. So I will have to find the solutions. Of course, I have two solutions that are x equals 0. No question there from here. But for this one, I have to find the solutions with the quadratic formula. Can anyone give us the quadratic formula? Nor can you give us the quadratic formula? Hello? Noor? Are you with us?
Yeah, give me 1 second, sorry. So it would be x equals negative b plus or minus square root of b squared minus, or do you want me to fill that in right
Yes,
now?
yes. That will be better.
Oh.
Shvam, will you give us the quadratic formula here, please? Well, it breaks my heart that in calculus we don't remember how to solve a quadratic equation. That really breaks my heart. That's all I can say.
Wouldn't it be 8 plus or minus the square root of negative 8 squared minus 4 times what?
Very good. Okay.
Yeah, over 2 times.
Good. So this is 24, and 24 is 4 times 6, so this is 2 to the square root of 6 divided by 2. And we have to simplify. Do not try to simplify 2 and 2 like this, or 8 with 2. You either separate or you factor out a 2. You can say, but why would I even bother? I need to approximate those two anyway. That's true too. I completely agree. If you say that, I will agree with it. But the exact number, is 4 plus or minus the square root of 6. But yes, I have to approximate them. If you ask me to plot this, I will not know where and how, right? So I have to approximate it. Yeah, this is 2 and a little bit plus 4, but I still would like to get it closer. So 4 plus the square root of 6, roughly 6.45, and 4 minus the square root of 6, 1.55. Okay. So I will put these here as 1.55 and 6.45 and 0 and 0. These are the x-intercepts and that. That's it. Now we're ready for the first derivative. Can anyone give us the first derivative for this function?
X to the third minus 72.
Yes. Very good.
To the second
Plus
60x.
60x. Very good. Obviously, critical numbers will only come from f prime of x being 0 because this is always defined. Again, I have to write 12x cubed minus 72x squared plus 60x equals 0. What will be the next step?
You pull 12x out of all of that.
Yes. I will never, in an equation, I will always divide by the constant. I cannot divide by x, but I will divide by the constant if I can. So it turns out that I have x cubed minus, I think, correct my mistakes if any, x squared, and I think plus 5x. Only now, after I clean it up completely, I cannot divide by x. I will pull out x and get x squared minus 6x plus 5. And now, can anyone give us, who hasn't said anything yet, like Noor and Shvam, I would like you to factor this for me. Alex?
X minus 5 and x minus 1.
Very good. X minus 5. Thank you very much. So obviously degree 3, you will give me 3 solutions. What are those solutions?
0, 5, and 1.
Very good. 0, 5, and 1. Awesome. So, of course, because I'm crowded here, it had to be 5, right? And 1, of course. My table is too crowded. I'm going to rewrite it. I'm going to write it here again because I don't like it there too close. You don't have to do that. If you can erase, erase. I need to have space between those numbers so I can explain what I'm doing. So I'm going to put 0 here and 1 here and 1.55 and 5 and 6.45 and infinity. Okay, so I have under 0, under 1.55, under 6. And then infinity is here. And I have, of course, 0 and 0 and 0. Okay, much better. And now I have to study the sign of this between negative infinity at 0, between 0 and 1, between 1 and 5, between 5 and infinity. 1, 2, 3, 4. So I personally prefer to rewrite, I'm going to rewrite this first derivative here, indeed with 12x in front and x minus 5 and x minus 1. This is the first derivative factored. Now, if you want to plug in negative 10, this will be negative, this will be negative, this will be negative. What is the sign of the outcome?
Negative.
Excellent. Now I'm going to have to plug in 0.5. I put it up here because I'm not going to use it as a point. So with 0.5, this is positive, but this is negative and this is negative. What is the sign of the outcome? See how many applications the product has? Excellent. I didn't want to plug in that. Oh, you can say, use the calculator. That's fine, you're right. If you say that, plug this in the calculator and then I'll plug in those numbers, that's fine too. I agree. So what is the sign with 0.5?
Positive.
Very good. Let's say between 1 and 1.5, I will put 1.1. I wanted to put it up here. I'm not going to use it. So this is positive, this is negative, but this is positive with 1.1. What is the sign?
Negative.
Perfect. I could have used 4. Negative, positive, positive. And now let's use 10 or 6, or it doesn't matter. What would be the sign?
Positive.
Very good, awesome. Now I need to determine this y value and I need to determine this y value. So I will plug in the function in y equals, which is 3x to the 4th minus 24x to the 3rd plus 30x squared. And then second in table, I want 1 and 5. 1, enter, 5, enter. So for 1, I found 9, and for 5, negative 375. Woohoo! Okay, perfect. So now the moment of truth. If I realize that there is some glitch in here and they do not communicate perfectly, then I'll say oops and start from scratch. Or without the oops, but I start from scratch. What does the function do here?
Decrease.
From positive infinity to 0. Is that correct?
Yes.
Perfect. What does the function do here between 0 and 1?
Increase.
Is that correct?
Yes.
Perfect. What does the function do here?
It's the same.
When the derivative is negative, what does the function do?
Decrease.
Good. From 9 to 0, is that correct?
Yep.
From 0 to negative 375, is that correct?
Yeah.
Good. What does the function do here?
Increase.
Good. From negative 375 to 0, is that correct?
Yes.
And from 0 to infinity, is that correct?
Yes.
Okay. Good. We move on to the second derivative. Now I'm not going to use this. I'm going to use this to find the second derivative.
I have a question.
Yes, please.
So do you make different tables for each derivative?
Say that again.
Do you make different tables for each derivative that you find it?
The first derivative is here. The second derivative will be here.
Okay, no, because I see that the first you add a first table and then you're making another table. Like, are you gonna make each table? That's what I'm asking.
Not good enough.
Okay.
It doesn't give me enough space. I didn't want to squeeze in here. It was just so crowded on this little piece. It was too crowded. We've never created two tables for any of these functions, right?
Yeah, I was confused. That's why.
I didn't have enough room. I didn't know that all these numbers will be so crowded, so close to each other. Is that okay?
Yeah, that's okay.